In this video, we're going to be using the unit circle to find exact values. So a couple of things you need to know before we do this is you should have a unit circle. You need to know the coordinates of the unit circle are written in alphabetical order. The x is the cosine fraction and the y is the sine fraction. If I ask you for secant or cosecant, you'll just need to flip your cosine and sine fractions and rationalize them. And if you're asked for tangent or cotangent, you're going to need to use these identities here. We will use these identities a lot in class, so hopefully with all the practice we have today, you will have them memorized. But tangent theta is secant theta over cosine theta, and cotangent is, remember you can flip your fraction, cosine theta over sine theta. Okay, so you need to have all of that, keep all of that in mind along with your unit circle as we work through these next million examples. Find the exact value of sine pi over 4. All right, look at your unit circle. You are going to go to pi over 4, and remember the coordinate points are written in alphabetical order. It's kind of, there's a glare there so you can't really see, but this is cosine, sine. So at pi over 4, my sine fraction, my y coordinate piece, is square root 2 over 2. And that's it. So when you're asked cosine and sine, it's fairly straightforward. All right, what about if I ask you for secant pi over 4? Remember, secant is the reciprocal of cosine. So secant and cosine go together. Okay, so that means I'm looking at pi over 4 again. And this time, the cosine piece is square root 2 over 2. All right, well, secant is the reciprocal of cosine, so I can't write square root 2 over 2. I have to flip that fraction. All right, I personally don't ever want you to have square roots in the denominator, and when we deal with the unit circle, you shouldn't leave a square root in the denominator either. So rationalize your denominator and simplify your fraction. My 2 over 2, neither one is under a square root, so I can cancel them. So the secant value for pi over 4 is square root 2. All right, now let's do tangent pi over 4. Well, the tangent identity is tangent equals sine over cosine. And since tangent is pi over 4, sine and cosine both need to be pi over 4. Let's look at pi over 4. Here's my sine value and here's my cosine value. On the unit circle, we will always have the same denominators. So instead of having to write the whole entire sine value over the whole entire cosine value and then do a keep change flip because we have a weird double fraction, we just have to look at the numerator. So only when we're looking at the unit circle can we just say, hey, let's look at this numerator and this numerator. So sine over cosine. We just want the numerator parts. The sine of pi over 4 numerator, I guess I should write that, is square root 2, and the cosine pi over 4 numerator is also square root 2. Simplify your fraction, 2 over 2, they're both under square roots, they can cancel each other out to be 1. All right, example D, cosine 5 pi over 3. Let's finally deal with something besides pi over 4. On your unit circle, 5 pi over 3. Here. And look at your coordinate point, they're in alphabetical order, cosine, sine. So cosine of 5 pi over 3 is positive 1/2. All right, negative numbers look weird and sketchy, but all you have to remember is for a negative angle, we can look at our unit circle straightforward, but you have to flip your y coordinate. So because this is a negative, I can look at my unit circle straightforward, but flip my y coordinate, the sign of my y coordinate. All right, so cosecant of negative 5 pi over 4. Cosecant is the reciprocal of sine. I'm going to go to 5 pi over 4 like normal on my unit circle. And look at your coordinate point here. Sine is the y piece. But this wasn't just a normal 5 pi over 4, it was a negative 5 pi over 4. And when that's a negative, I have to flip the sign of my y coordinate only. So instead of this being negative square root 2 over 2, it's positive square root 2 over 2. Okay, y coordinate point is the sine piece, so I need to take that positive square root 2 over 2 and flip it to get my cosecant. And then rationalize and simplify. You'll notice that a lot of these, we're using the same fractions over and over and over again, so you'll notice that you keep getting the same answers over and over and over again. That's not a coincidence. Well, I guess it is, but that's how the unit circle's set up. Let's just keep going. Find the exact value of tangent negative 5 pi over 4. So again, I'm going to look at normal 5 pi over 4. It's a negative 5 pi over 4, so I need to change my y coordinate. The sign, it needs to change from negative to positive. And if it was positive, then you would change it negative. It's just whatever the sign is of the y coordinate, SIGN sign, you change that. Okay, so for tangent, remember it's sine, S-I-N-E, over cosine. So I'm going to take just the numerator, positive square root 2 over negative square root 2. Leave the cosine piece as is. You just change this to a positive. So tangent is sine over cosine. And we're just looking at the numerator. We changed that to a positive square root 2 over 2 because this was a negative. But our x piece stayed negative. All right, the square root 2's cancel out or they simplify to 1. And overall, this has one negative in it, so it's at one negative fraction. Okay, let's keep going. Oh, we can finally deal with degrees, which is what I think most people enjoy better than radians. But in calculus, you deal with radians. Secant is the reciprocal of cosine. So we want to look at 180 and look at the y coordinate. So at 180, my y coordinate is negative 1. But this wasn't just 180, was it? It was negative 180. And at negative 180, you need to change the sign of the y coordinate piece. Well, 0 doesn't have a sign, so negative 180 and positive 180, nothing's really going to change there. And regardless, we're looking at cosine, which is the x piece. So take the x piece, the cosine, and flip your fraction. So normally we would have cosine equals negative 1. You can write anything over 1 to create a fraction and then flip your fraction. Well, negative 1 over 1 and 1 over negative 1 is all the same thing. It's just negative 1. Let's look at tangent 180. So we're going back to 180. Remember, tangent is sine over cosine. And we're just looking at the numerators, although in this case we don't have fractions, so sine over cosine. Okay, these are in alphabetical order. Cosine, sine. So sine is 0, cosine is negative 1. 0 over negative 1. 0 over anything is 0, so that's it. Cosecant of 180. Cosecant is the reciprocal of sine. Let's go to 180. These are in alphabetical order. Cosine, sine. Sine of 180 is 0, but this is a reciprocal, so I need to flip. If sine is 0 over 1, flip your fraction. 1 over 0, uh-oh, you can't do that. So for cosecant at 180, we call that undefined. Because if 0 is under your fraction, it's undefined. Okay, 2 more. We're slowly getting more and more difficult, but I'm hoping you're sticking with me. If not, please let me know and we can do more examples together in class. Secant of negative 390. There's a lot going on here. First of all, we're dealing with secant and not just straightforward cosine, so we have to take our cosine fraction and flip it. Next, we're dealing with negative angles, so we're going to have to look at our unit circle and flip the y coordinate piece. And also, we're dealing with something that's not even between 0 and 360. 390 is bigger than that. So, you need to find coterminal angles. Remember, coterminal angles, you add or subtract 360, or add or subtract 2 pi if you're in radians. So let's add 360 to this. All right, I could just deal with this as a negative 30, but let's just do coterminal angles again so we don't have to deal with negative angles on top of all this other junk. Much better. So secant of negative 390 is the same thing as asking for secant of positive 330. This is scratch work. All right, we're going to do the same thing still. Secant is the reciprocal of cosine. So at 330, I need to pick out my cosine fraction and flip it. So square root 3 over 2 needs to be flipped. What was that? Square root 3 over 2. You cannot leave a square root in the denominator in my class, so I need to rationalize it, but luckily that's all we have to do because 2 over 3 doesn't simplify any further. All right, we're going to do the same thing with this last example, cotangent of 17 pi over 6. 17 pi over 6 is bigger than 2 pi, so it's not even on our unit circle. So we need to subtract 2 pi in order to find a number that is on our unit circle. So if we subtract 2 pi, remember that is the same thing as subtracting 6 times 2, 12 pi over 6. You have to get a common denominator. 17 minus 12 is 5. So cotangent of 17 pi over 6 is the same thing as asking for cotangent of 5 pi over 6. Cotangent is cosine over sine. And just like we did with tangent, we only have to look at the numerators. So let's go to 5 pi over 6, cosine, sine. And we just look at the numerators. So negative square root 3 over 1. And then because it's silly to write that over 1, our answer is just negative square root 3. For all of these questions, you need to keep in mind your coordinates are written in alphabetical order, cosine, sine. You can flip your fractions if they ask for secant or cosecant, and use tangent equals sine over cosine and cotangent equals cosine over sine to get those two values if they ask for tangent and cotangent. Also, if they give you a negative angle, just look at your coordinate point straightforward, but flip the sign, plus or minus sign, of the y coordinate piece. And if they give you something that's not between 0 and 360 degrees or 0 and 2 pi radians, just add or subtract 360 and 2 pi until you get to something that is on the unit circle.